All right, I think everyone's settled in. You can jump in here. My name is Jesse Barnes. I work in the Intel Open Source Technology Center with Daniel, who just presented, and several others who are here today on the INM15 graphics driver primarily, and then miscellaneous other GPU-related stuff inside of Intel. Today, I'll be talking a little bit about the Intel BayTrail platform. And I had actually wanted to cover this last year, but I only got approval to talk about anything in any detail this year, so push forward. So some of this may not be totally new to you, especially if you've been reviewing what came out of IDF a couple of months ago on BayTrail. But this is something I'm really excited about because it's a new SoC for us in a couple of ways. It's got a new CPU, a redesigned Atom CPU, and a new GPU relative to our previous SoC products. So it's really interesting, and we've also been involved on the bring up and some of the design work from very early on in the open source side of things. So it's exciting for us from that perspective as well. It wasn't just totally driven by Windows stuff or powered on solely with Windows, that sort of thing. So anyway, like I said, this is a new SoC specifically focused at like the tablet market and convertible market. It's not designed to go into phones. It doesn't quite have the power envelope that you would need for that and the level of integration you need for that, but it does make a pretty decent tablet chip. It's working, or it's fabbed on our 22 nanometer process, which isn't our bleeding edge, which is the Broadwell stuff that we're pushing out now that's on the 14 nanometer. But our 22 nanometer process is pretty good. It's pretty mature and works well for us. They're really big. I mean, it's a really big change, both CPU and GPU wise for us on the SoC side, on the Atom side. And like I said, the Linux stuff was a priority from early on. And the Linux team has been involved. Our open source team doing Linux drivers has been involved from very early on. We were at the power on when the silicon first came back from the factories, doing the initial debug and development of our driver stack. So Ben, who may be somewhere around here, was at that. Ken Gronke, who's on the Mesa team, was there helping, and we got 3D games up and running and stuff within a day or two of getting stable silicon. So that was really exciting. So some of these slides you may think, oh, these are really pretty. How did he come up with those? Well, I didn't. These are mostly stolen from IDF, so hopefully they won't be too full of marketing stuff. But this is the overall architecture of the chip. So it is an SoC. It's got a whole bunch of IP blocks on it. But the big changes are the new Atom up to quad core, and then the new HD graphics, which is not new from the client side. It's basically an Ivy Bridge graphics part, but it's been chopped down and put onto the SoC. So if you're familiar, or if you've been following our previous Atom stuff, you'll know that earlier chips used IP block from Imagination, the PVR graphics stuff. And I'm sure everyone has a lot of love for their stuff, and they'll be sad to see it go, but now we've got Gen graphics instead. So you'll have to tolerate that. And then, it's got kind of similar feature set to what you'd see on a client part. There's the CPU and graphics power sharing, and, the same sort of ISA extensions for security and virtualization. That sort of thing is all present. So it's, it looks like a regular client CPU, and it actually has a similar speed. So like I said, these are kind of the key changes. So the big one on the CPU side is going to the Silvermont architecture, which I'll talk about in a second, and then the graphics side going from the SGX, running at a lower frequency to the Gen graphics running at a higher frequency. And of course, it's a totally different rendering model too. It's not a deferred tile-based rendering. It's immediate. Resolution's increased, and in fact, we go up on the Linux driver. We go up higher than 25 by 16, thanks to the mode setting architecture stuff that Daniel was talking about. We're able to change the display clock, the core display clock at runtime, if we need to bump up to an even higher resolution. Memory bandwidth is dramatically increased. So on some of these SKUs, like on the convertible tablets and notebooks, you get like regular PC style memory bandwidth, which is really great. And we went up to new USB as well. So that's also important, so you don't have to wait forever for your multi-gigabyte USB stuff. Overall, This is what the kind of basic block diagram looks like, and this is a bit different than what you would see on a client platform. It doesn't have like a QPI bus. It's a custom ring fabric that we use on the Atom side, just within the SoC. One of the big differences that we have relative to the client parts, at least since Sandy Bridge, we've had the GPU is able to share in a cache coherent way the last level cache on the CPU, and so they're both, the GPU and the CPU are integrated on the same die, and they can share the last level cache. On here, they're integrated on the same die, but we do not have that cache sharing. So each of those dual core chunks of IP has their own shared cache, but it's independent of the graphics. So that makes for quite a different set of performance characteristics. So if you're tuning for performance on this part versus, say, an Ivy Bridge laptop, you're going to see very different things because of that lack of cache sharing. So you have to be careful about how you map and read back memory, and also how you set up your rendering and things like that. And it has it has the Intel HD graphics plus the quick sync stuff that you would see on the client side, so it can do the regular video decode and encode you would see in the client space. And in addition to that, we've got a VP8 decode engine on these parts that's available and used in some cases. This one looks really marketing-like, but the kind of takeaway for this one is the huge improvements in power or performance. You get to choose. The huge difference here is this is the first Atom part that's out of order. So if you've looked at our previous microarchitectures on the CPU side, they've been in order, maybe dual issue. Now we've got up to 4 cores out of order, and the performance is just dramatically improved. If you use one of the old Atoms, it's like using an ARM platform. You're like, I don't want to do any builds on this. I don't want to actually log into this machine. I want to just copy stuff onto it and kind of pretend it's not there. This guy, you can log into it, and it's like using a Core 2 Duo laptop from a couple years ago. I mean, it's like reasonable speed. You don't want to stab your eyes out when you're using it. So it's a huge, huge improvement from that point of view. And it's got the new architecture extension. So it's a reasonable CPU to deal with in terms of having the feature set you're used to. And there's all the fab stuff if you're interested in the 3D gates. So this is some of the benchmarks we've done comparing the new Atom CPU side to some of the competition. Like I said, the other guys, these are fast ARM CPUs, but they're still terrible, right? I mean, sorry if there are any ARM folks in here, but I can't. I used Atom, and like even our old generation Atom was pretty competitive. Like it actually beat out some of the ARMs. And in using it, I'm like, I don't understand how the ARM guys even survive. Like, this is a terrible thing to use. I don't want to use this platform. This new one is like, it's significantly faster. So you can see, I mean, these are spec in. So this is like what, this is your kern bench basically, right? And it's way, way faster. And the power consumption is also lower. Some of these guys, I don't know if this is actually ISO power, but you can see at least the clock rate. Yeah, Greg's saying the Tegra even takes more power on this same benchmark and gets less performance. And I don't know. There's legal disclaimers at the end that I don't know what I'm talking about. So, yeah, I'll just agree with that. Like I said, the next big chunk is the graphics side. So, getting rid of imagination. Imagination is, for their faults, they're tuned to work in the mobile space and tend to be fairly power efficient and can achieve high performance. I mean, if you look at the latest iPad Airs, they've done pretty amazing things with that architecture. It's proven. I don't like to work on it because it's a closed source driver stack. It has a different architecture than what we have, and I'm more used to ours. So I'm really happy about this change because we have a fully open source stack. But that's mostly a personal preference. From an Intel perspective, I think we have an opportunity here to really prove this architecture out in a lower power envelope, and I think we're doing that in BayTrail. So like, you can see that it's only got 4 EUs. Like, it's a pretty simple chop down from the client side Ivy Bridge, So the performance is kind of scaled down on to what you'd expect, minus the LLC sharing that I already talked about. And all I can say is, in terms of the future, is just keep your eye on this space. It's going to get pretty interesting this year and next year. And then I talked about the power and the video decode stuff. It's all available too. Here you can see the gaming side. So this is basically comparing the graphics performance. This isn't a leadership part by any means from a graphics perspective. It's merely competitive. To me, this is actually pretty impressive, given that it is a fairly straightforward chop down versus like a dedicated redesign for mobile. The fact that we did this well without a tremendous amount of effort tells me that we have quite a bit of room to improve, and the subsequent parts should be really nice. Plus, we've got an open source stack, so that's pretty exciting. And yeah, it beats the crap out of our old stuff. I don't know if there are any media folks in here. There's so many acronyms and different codecs. But it does have, like I said, it has the same encode and decode support and transcode support that you would see in the client part. So that's nice from a like teleconferencing or video calling, that sort of thing point of view. So all that stuff is there, and that's actually a really nice feature of our parts. And I probably ought to know more about it, but I don't spend much time on the media side. On the display side, at 10 by 7, you can't really see this. This is a chamber of horrors. There are demons hanging people and torturing them. On the display side, the pipe stuff and the register block on the display mostly matches what you would see on the client side. But when you get out to the port side, they redesigned everything and did a custom implementation of the display PHY itself. That's the chamber of horrors, and it's been a thorn in our side. I think the hardware guys really take pleasure in torturing us. It's just a totally different programming model. We have a very low-level access to all of the PHY characteristics and all of the filtering and things that get applied on the DAC for the PHY. So that's been a challenge to get right across a variety of configurations. But on the plus side, we've got MIPI here, we've got 4 by lanes display port, and we can actually go up past 25 by 16, which was mentioned earlier. I think we're at like 38 by 18 or something like that. So it's not a bad display part either, and it's relatively low power. We have some power gating features that we can do, like when the pipes go off, we can actually power gate the whole display engine. Like we do on the graphics side or on the render side. When the GT's idle, we can power gate that. So we have that support on the display side now too, which is really nice. So the low level aspect of it is a pain, but we mostly have it under control now. So this is what we're shooting for. This is like a display on idle case, where you're just looking at your screen, but you're not doing anything. Or maybe you're rendering a little bit. You can see the graphics is lit up. But what we're shooting for on Linux is this. When the display goes off, we want the whole SoC to basically go off and power gate everything. So there's just some like tiny microcontrollers and things that's still awake. But this is not a full S3 state. This is a runtime suspend state. So the SoC architecture that we have now lets us get to really low power consumption during runtime. Greg asks, are we going to bother with S3 because we can do runtime suspend? Yeah, S3 in some cases can still save you a little bit more than a full runtime suspend case, so we'll support both S3 and runtime suspend all over the place. Going forward, if we can get parity between S3 and runtime suspend, I think at some point we may just implement S3 in terms of runtime suspend, but there's a logic and there's an overhead to all of the runtime stuff. So S3 is also simpler from a platform and implementation point of view. So there's trade-offs. So the upstream status of this, we started pushing these bits way back almost 2 years ago now. Landed the initial graphics stuff in 3.6. And the full S0ix, that's our runtime suspend support, isn't pushed upstream just yet in the core side of things. And then on graphics, that's pretty much done. We just have to get it merged. Things really stabilize around 3.10. So if you're starting to get these platforms for yourself, don't do anything before 3.10, or you're going to be in that chamber of horrors that I talked about. The display up and down clock I talked about, so I don't think any of those super high-res display products are out on the market yet, but when they are, we'll be ready for them, so you'll be able to use those right away. RC6 is a feature on this too, and it works. I know some of you may have had problems with that. RC6 on BayTrail is a different implementation than it is on the client side, and it's actually simpler, and it seems to be pretty stable. We've got some display power shutdown stuff like I talked about, some other display features that are actually not BayTrail specific, the dynamic refresh rate support. So like if the screen is mostly idle, you could actually drop the refresh rate, save some power on your memory bandwidth, let your memory stay in self-refresh for longer. We have some bugs, again, Chamber of Horrors. This one we just fixed the day before I caught my flight out here, and that had been driving me nuts for a week and a half. So I'm really happy that we fixed that. So if you're buying a BayTrail based platform on Amazon or something now, you would have run into that like right away, but we've got that under control now, so that should be fixed in the current kernels, and we'll push that back to stable. And then there's some other issues, like Alan Cox got this T100 machine with a BayTrail a tablet SKU in it, and it had it's actually a MIPI based panel on his machine, but it showed up as a VGA for some reason, and he was, as he was trying to configure it, he's like, oh, I can get it to work if I program the VGA to do this, and it just so happened that he was programming the VGA in such a way that we were driving both VGA and MIPI with the same timings, and the display happened to work. So there are still some things we have to work out on the MIPI side. We haven't tested it tremendously, just in upstream Linux. We have it on our Android trees, but so we'll see some improvements there. On the Mesa side, it's been in for a long time, since Mesa 9.2, and even before, I think. There's a lot of performance headroom here. Like the performance for some things is actually looking pretty good, but for other things we're like at half the speed that we could be. So the Mesa team's just kind of continually improving performance there. Ian is probably not here since we were out last night until about 6:30 a.m. But you can ask him later when he shows up. On the media side, it's been supported in libva as of the 1.2.1 release. The VP8 stuff is in progress. The way that the VP8 bits are integrated, it shares some logic in terms of power gating and interrupt support with the i915 IP block. So there are some i915 changes required, and then there's a bunch of a driver in our Android tree that's published in open source, but it's not integrated upstream. And I don't know if the people we have working on it are actually going to push it upstream or not. It might land in staging at some point, but it's pretty ugly still, so we're working on that. There are a few platforms out there now, mostly Windows stuff. I keep refreshing on Amazon until, because I want to see the Android tablets come out, but I think those will be coming in the next couple of months. Or if you go to Shenzhen, China, you can have them build you one right now. That's been another kind of issue, but people building weird configurations and saying, hey, it doesn't work. And if you're looking for the SKUs, I just included them here. You can also jump on Wikipedia; those are all there. But if you're on Newegg or something and you want to look, there's a new NUC, the next unit of computing. Intel's, it's kind of a side project for Intel. Nice little tiny form factor device, but there's one with BayTrail in it now. There's a new one with Haswell and a new one with BayTrail, and so both of those are really nice platforms for a tiny device like that. And the BayTrail one hopefully is fanless. So that's a fun way to get your feet wet with BayTrail if you want. And then there's new stuff coming, so just keep looking. Okay, legal disclaimer. Anything I said you can't hold against me because I'm a fool. Yeah. So any questions?
Hello?
I can hear you.
So you're going to be, on the Mesa side of the graphics, you fully support OpenGL ES 3.0, and when you bring this over to Android, you're obviously going to be supporting it there as well. Will you be bringing desktop OpenGL to the Android side while being able to create it with an EGL context?
Will we be bringing full OpenGL to Android? That's not something that we're going to stop people from doing. I don't think Google has any plans to expose the full GL API through their framework, which is really what would be required. But if you want to take build Sanogen with Mesa and enable full GL in your build and then do NDK stuff, that's definitely doable, I would think. On Android, there's like some additional complexity because they've got a GL wrapper library to kind of unify the feature set. But yeah, it's something that you could definitely do if you wanted to. I guess Ian's still not here, but he would be a good one to ask about that too. Any other questions? No? Cool. Well, I'm glad I got to brag about this. I've been excited about this platform, and I'm glad it's finally out there. Thanks.
So next talk is going to be about Nuvo. It's going to be